Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video today is going to make a Pac-Man clone, and we're going to actually create and steal and use the actual arcade AI, artificial intelligence, and pop that into the game. And we're going to use GameMaker Studio 2.3, and we're going to use GameMaker language, and we're not using any of the drag and drop stuff. So before we get started with any of the actual gameplay and coding, we have quite a bit of stuff to put into the game because I'm going to try to mimic everything as best as I can. And so you can see here is my layout for my room. And, that's interesting, the tiles and all that. But let's take a look at all the things that we need to create for this thing to work properly. Let's see. The first thing I see here is I actually made, this part I pre-baked this because this took me quite a while to get going. There's a lot of tediousness, and I haven't even added all of the tediousness to this yet. But you can see I have three layers. I have my background layer, which is using a black background. I have an instances layer, which I will describe here in a little bit. I have tile layer, and the tiles are actually drawn on top of everything else. And so if I eliminate the tile layer, you can see what I have going underneath here. I only have these white walls, and I created these walls. So you say, first thing off, my room is 720p resolution. I don't know why this tiling is so... Anyway, but the room is 720p. I have all of the graphics in here centered. I have these, whatever they call, placards or something like that. I have the side walls for the game. I'm only doing this to make the game 720p because my students are going to need 720p resolution. If I weren't doing something like this, I probably would reduce it down. I forgot if it's 480 or something like that, or whatever it is, whatever I got going for me. So what I did was, this is the actual level from Miss Pac-Man. This is the third level. This is where the pear and the banana come out to play for that game. And so what I did was I created a wall sprite. I made them 20 by 20. And so every one of these sprites, you got to make sure that our tolerances, our collision mask is set up so everything is in a good place. But I used 20 by 20 sprite for that. I used an object that is solid because we're going to be using move contact solids because that's my way of doing things. But what's interesting is I didn't make them visible because they don't need to be. They need to be solid and part of my game, but I don't need to draw them because we're going to be drawing on top of them. So there's no reason to spend that time and effort to have the CPU draw something that's never going to be seen. So 20 by 20, and then I just, I found the graphic and I just started working my way. It was a little challenging. Let me show you that again. It was to kind of get things going, because it's a little, I got it working, I got it looking good, but it did take some effort to get this to be exactly like the level was supposed to look like. And so I put these placards immediately to the left and right. And the reason why I'm going to use this is eventually I'm going to play with the bounding box on this. So when you're moving and you collide with the bounding box, it'll, like Pac-Man can go all the way around to the other side. I'm going to actually be using these to determine if Pac-Man needs to wrap around the screen horizontally. So, and basically, just to show the instance grid and show everything by 20 by 20, I really did just go in here. Oh, actually, no, I didn't. Actually, I did it originally on the left-hand side of the screen, and then I shifted everything over to center it. And so that's why everything seems to be off by 10 pixels at a time. And actually, that might cause an issue later on when we go to add the dots, but we'll see. And say, things are not always easy. Like, the drag and drop elements are there to help us, but they're not always there to, to make our lives perfect. And so I just went ahead and just filled in and just basically just use the tool to just put the objects in, just, put them in whatever I had to do, and then just put them in a nice order. Then I put the graphics. For the graphics, I have these. These are 720p height when it comes to this, so it's the full height. And then I just mirror imaged it or whatever I had to do to make it so that it looks, looks nice from the left side, looks nice from the right side, and there I have that. And then what I did, say the tile layer itself, I went in, you can see I created this image myself with my grand art skills. You can see you can see how great my art skills are there. And so I went ahead and created all these different little tiles. These are all 20 by 20 tiles. And then I just went ahead and I filled in. It didn't take too long. I know you can do auto tiling and learn the brushes and things like that. I did make an effort at that, and things did not go well. And for the moment, I was like, it'll take me more time to learn that right now than it is just to do this. So I fiddled with this, put the images in as best as I could, and then I just went ahead and painted over, and it looks pretty good, right? So maybe it's a little more challenging to see, but I have the lighter orange, pinkish, whatever color that is, and then the darker color for the border. And I just made sure that all the border, it looks like it's supposed to look all the way through. And I say, like, so far I haven't found anything that looks out of place. But the same thing goes with the graphics versus, actually yeah. This is why when I do the grid, this is why everything looks a little weird, because I did an offset on the tiles to match up so that I'm drawing completely over the wall objects themselves. And so yes, so you need to take that tile layer and shift the whole thing over 350, because that's what brings me into having everything. Because you just say, I remove it, you can see I'm just going right over everything by doing things 350 over and having the instances shifted over. You don't shift them over in here, but you use like the shift tool to take everything and move over and stuff like that. That's how you would do things there. Okay, so about 7 minutes of talking, blah, blah, blah in there, and we are pretty much where we need to be to start thinking about all the other parts. Oops, I didn't mean to block that per se. But now, when I run the game, it looks exactly like I'm expecting it to in 720p resolution. And there we go. And I made, with the 720p resolution and 20 pixels per vertically, we get room for the top where we could put scores, and the bottom where we could put how many Pac-Mans we have on reserve, and then which fruit is the current fruit. And we're not going to go too crazy on this, but my job is always to show you the basics and give you the foundation to push forward and make things nice. Okay, so there we go from there. I'm going to do Pac-Man, Miss Pac-Man first. And so what I did was I found a Pac-Man Sprite. For all things, this one is not hard to do. I found this, maybe not that Sprite. Well, you can see there's a lot of different images. And I just pulled it in. Let me just to show you here. This one right here, Miss Pac-Man. And so all good there. And so yep, I just brought it in. And the thing was, though, because my sprites came in 32 by 32, which you would expect from an old video game, I went ahead and when I pulled out all the individual images, I upscaled everything to 40 by 40. So all my Pac-Man sprites, here's my Pac-Man down, num 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 num. Here's my Pac-Man up, or I'm sorry, left. Here's my Pac-Man right. Here's my Pac-Man up. All of them are 40 by 40, and for the moment I went ahead and I manually changed all the bounding boxes to be the full image. We might go back and change that in a little bit. We'll see how it looks when we go to put this into the actual game. And so there we go there. So 40 by 40 full images. And then the one thing I did here was I did tinker with the frames per second, so I don't have to write code. Normally I'm against that, but as long as everything has to be consistent for now, I think it'll work for us. 10 frames per second, and we'll see. Maybe we'll have to fix that, and then we can fix that in code if we have to. But that's what Miss Pac-Man will look like while she's walking along eating all the dots. Okay, so let's move on to putting Pac-Man into action, and it's very similar to a lot of the other objects we've been doing, especially with the move contact solids and that. A little different because as long as Miss Pac-Man, Miss Pac-Man or Pac-Man doesn't stop in the middle of a corridor, you have to, basically, it'll stop when it hits a wall, but it won't stop in between anything else. So you have to be careful with that, and we'll find a way to do that right now. Okay, so we need a Pac-Man object. I'm using Miss Pac-Man, but Pac-Man, whatever you're using. Nope, not a sprite. Delete that. And I keep forgetting everything's in alphabetical order. All right, so Pac-Man. And I'm going to use the Pac-Man Right sprite for this. Get ourselves going here. And so putting this object in the room, not be overly challenging. There we go. Oh, no, it goes down here. There. And actually, that works out nicely. Okay, so it's all centered nicely. And then if I run the game, let's see how fast Pac-Man's biting. Num, 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 num. Let's see. Yeah, that's not bad. Again, maybe we change that if you're not happy with it. But for right now, everybody's good. Alrighty. I think that's the way Pac-Man starts the game. I'm not going to go look at it, but we'll just say that. Okay, and so we're working that out, and then we're going to say on create, we're going to say, oops, little thing is moving. Okay, we're going to say image speed is 0, so only when you move around will it allow you to keep biting, because otherwise you'd be biting into the wall, and they're like, oh, that's not how things go. So this looks pretty good there. There's my Pac-Man. Okay, and now we can start applying step events. And then just for getting the key presses going, I'm going to set directions, because you can go one of 4 different ways. If keyboard check, and I'm just going to use the arrow keys. You can use whatever you want, of course. Virtual key, if I press left, then my direction will be 180. And I'm just going to use 4. And you can, I'm not going to fight out what do I do if 2 or more buttons are pressed at the same time. I'm not going to worry about that just yet. Uh-oh, what did I do wrong? Nothing, I didn't do anything wrong. And I got to go back, okay, left and right. Obviously right is 0. And then up. And up is 90. And down is 270. And then all I'm going to do here is say move contact solid. And I know I have my move slide solid, but since we're only going to be moving one cardinal direction at a time, you don't need that slide solid function. This will work just fine. And I say direction, and my Pac-Man speed. I'm going to put Pac-Man speed here. And so I'm going to set that up in the create event. And what's going to happen here I can change this information, but not this. And so I'm going to say, what numbers am I going to use? I'm going to use 4. And since everything moves 20 by 20, the only thing you can do, you can set to anything that's multiple or divide is divisible into. So I can say 1, I can say 2, I can say 4, I can say 5, I can say 10. And that's just to keep the math easy, so that these, when I do, if I do this, if I do 1 20 times, 20 times 1 is 20, 2 times 10, 4 times 5, 5 times 4, 10 times 2. Whenever I go a certain number of frames, I will hit, and I will move, basically like the Frogger game, I'll move it 1 tile over, so that I don't have to do any extra math to see if I have to kind of realign myself so that I can change direction. That might be it outside of the animation. So there's Pac-Man, up, left, up, right, left, and there you go. Oops. Okay, so there's a little something here. If I'm going left or right and I try to press up, I'm stopped. So I do have to write a little bit of code to handle that. But otherwise, everything is kind of in place. Like I should be able to press just right and then hold down, and then when I get to there, I should be able to slide on in. So there's a couple little minor details here that we have to work out. But otherwise, things are looking pretty good here. So I just have to add an extra check to every one of these. And again, it is tedious, but the whole, we write the code now and then we never, set it and forget it kind of thing. So if I do a place meeting, and I'm trying to go left. So if I just try to move 1 pixel to the left, or you can, 2, just keep it at, you could probably move a whole square over, but it's just a matter of just being nice about it. You don't have to do too much crazy stuff. And I say, okay, if, width a wall is false, then go that way. And let's see about this. So I go up. Yeah, you can't see, of course. Bring this over. Okay, so I go over to here, and I go up, and I'm holding left, and there I go. It did work. I know it's hard, it's impossible for you to see that, but I'm holding left, and it doesn't stop me because there's a wall there. So it's just a matter of changing this little thing up a little bit in all the 4 directions. So right, of course, is just a positive. All right, and then this changes, this changes to be positive or negative in the y direction. And this goes to be a positive in the y direction. Okay, so now trying this out. Right works, up works, down works, and left works. So now I don't have to go crazy having with skill. I can totally work this out. Of course, this isn't going to work yet. We're going to have to work that out in a second. Okay, I think we're happy here, right? Pac-Man is moving around. She's looking pretty good. When we get to the dots, I'm going to add a little bit of gameplay that you've maybe never noticed about Pac-Man. Because let's face it, Pac-Man is how many years old now? And you are way younger than Pac-Man for the most part. Okay, so I got that working for us. And so what I can do here is go ahead here now, and let's play with the sprites. And instead of hard coding this right now, I'm going to go into the Pac-Man object. And I'm going to say these are the sprites. Just in case you want to change things later on, you don't have to go in and change. So I'm going to say left sprite, right sprite, all this stuff. Left sprite equals, and I call it Pac-Man left SPR. Okay. Left, right, up, down. Left, right, up, down. Okay, so then let me just borrow this so I can, because I always forget since I'm talking and thinking and doing. So the speed is already set, and then this is all good. Yep, and it's unused, so you don't have to worry about that so much. And then go into the step event, borrow this, and say, okay, since for the brief moment I can say sprite index equals left sprite. Okay, now I don't, I don't need this anymore now that I know. My failing short-term memory. Don't get old, folks. All right, so let's see. I'm going right. Then I'm going up. And I'm going down. Let's see what that looks like now. Left, right, oops. And I did forget about the setting the animation speed, but at least the Pac-Man, Miss Pac-Man looks good, going left, going right, up and down. So yeah, so let's fix that up and say image speed equals 1. Just remember, at least I changed everything myself, so I can make it 1 and not feel bad about it, not feel weird about it. There we go. Pac-Man's biting now. And like I was discussing earlier, the only problem is that when I hit the wall, Pac-Man continues to bite, and I'm not going to worry about that for this video. There's a lot of other things to worry about. That's a design issue. If you don't like Pac-Man eating like that, then we can talk about fixing that up. But if you don't really necessarily care, then it's not a big deal. But Pac-Man for sure now, or Miss Pac-Man, totally walk around and do what she's got to do. Okay, looking good. So let's fix up this idea of when we do this, going around. And so it's really, those are just collision events for the most part here. So if I collide with the left side, I want to add some component to this. And I want to say x plus equals, and I'll say 480. Let's just, I don't know if that's right, so let's just try it out. So I go over to here. So 480 probably needs a little more than 480. So let me go ahead and duplicate this for collision with right side, x minus equals. And then let's just tinker with this to kind of get the feel correct. I just want to do this, I just want to play with this so that I can test both ways. So there we go, and there we go. Oops. So I'm thinking the sprite for the right-hand side is different. So let's see. Because nothing wasn't working, and then my right-hand side. Yep, again, everything gets screwed up here over and over and over again. I'm going to have to manually go in and fix this up. And just for the sake of right now, I'm just going to go to, so oops, 719 and 239. Again, just to test everything out, then we can tinker. But it's way too close, right? So I probably want to start setting this and change the sprite, the bounding box of this, so that it doesn't cover any of the black part. So I just need to change the left. I don't know what number. Oops, wrong way. Sorry. Oh, no, on the right one, that's fine. Just not too much. Oh, geez, I don't know. 20, 30. I wish I didn't have black here. It'd be a little. Oh, I could see it there. Maybe that'll work. Let's see what happens. You don't want it to be too close to there because you want to make it look like it's going off the screen a little bit. Okay. Oops. That broke doing that now. Oh. Well, whatever. I did the wrong testing. Let me go over here and fix this up. Oops. Excuse me, sorry. And so the right-hand side for this is going to be annual. Let's see, bring it down to 219. Let's see what that does. But I want to make sure Pac-Man gets drawn behind it. So let's just see what happens when we get over here. Yep, I don't know. Did it do it? Again, shoot, hard to know. So let's see. Our Pac-Man sprites, I didn't go ahead and change any of the centering or anything like that. So everything's upper left-hand centering. So what I can actually do to make this right is play around with it. So give me a second here. I don't want to waste your time. So give me a second here to play with the settings, and I'll tell you what I did to make it look nice. Okay, so I got it all figured out here. So what I did, I went back into the sprites, and I actually removed 40 pixels from each of the two sides. So for the left-hand sprite, I made it from 0 to 200. For the right-hand sprite, I made it from 40 to 240, basically. So there's 40 pixels on each side. And then what I did was I moved the Pac-Man to be drawn basically above. So Pac-Man will be drawn before these. So Pac-Man will look to be kind of disappearing behind these placards on the sides while it goes around. And so when it comes down to the code, what I did was say, when I went off on the left-hand side, I just said, okay, when I finally touched the placard, the bounding box for the placard, I say, oh, go over to the right side. Find the right side object and get its x value, and now you're going that way, and you're going left while you're doing it, so you're just going to continue to move left and everything works. Going to the right was a little more challenging. And this is to say, okay, when I go off to the side of the right, find the x value for the left-hand object and add the sprite width. And then, so you got to make sure you go past the sprite on the right-hand side. So all of those things combined get you to where we are now. And Pac-Man is, except for one little thing here, getting Pac-Man to stay still until you touch him or her. And so now I go across, and you can see there. Now it looks a lot better. It looks a lot more professional. It looks a lot more like it's supposed to be. when I go across from side to side. And it say Pac-Man doesn't get, the black of the placard gets drawn above the Pac-Man on top of the Pac-Man character, so we don't have to worry about it, not looking good. If you don't like that kind of thing, it's a little tricky. Maybe depending on whatever, you can play with the depth settings of Pac-Man too. You could go ahead and just say, let's say depth equals, and just use a +1 here. That will also do it if you don't want to go ahead and change your objects inside of here. And so, I mean, you won't see any difference, but oops, actually you will. Oh boy. Pac-Man's drawn at 1. I thought it would be the other way around. Let me try -1. That was interesting. Maybe they have changed. I've seen they've kind of changed the depth settings before, but let's see about this. Yep, apparently, no. It doesn't matter what I change the depth settings to. How interesting. I wonder why that is. So anyway, forget that. And for right now, just keep it easy. Figure, whatever. Just keep the Pac-Man above the side right and the side left inside of the properties window over here. There's a lot of walls and stuff like that. You could reduce that if you really wanted to, if that ever becomes a problem for you. But now let me just bring it back. That was weird. How did the depth settings do? Did I spell depth wrong? I don't know what happened. I wasn't paying attention 100%, I suppose. But you can see that's back to where we expect it to be. Okay, so the last thing to do, or two things to do. One is I want to make sure that when Pac-Man starts, you don't start walking or moving until the character moves you. So I'm just going to say direction equals, I'm just going to say 45. And the reason for that is, and 45 is the direction Pac-Man will never go. And it will be modified. The first time you touch these, it'll be modified. So as long as if direction does not equal 45, then I can move. So this kind of fixes the issue I was having earlier with Pac-Man moving to the right immediately. And now, what is going on? So place meeting. I'm not keyboard checking, no keyboard checkings. If direction does not equal 45, where the heck did I put, oh my God, where the heck is my code going? Didn't I put it in? Did I put it in the wrong object? Did I put it in the wall? Anyway, no, I did not put it in the right place. My bad. It belongs in the create. I said create, I just didn't do it. So there we go. That should handle it now. Sorry, guys. So there we go. Pac-Man is staying still, not moving until I press any key, and then everything moves and I can't stop him or her anymore. And now that's perfectly fine. I think that's a perfectly legitimate thing to do. Pac-Man can still go off the screen, do all the things. So the last thing we do right now is we got to add the dots. And this is tedious. So going ahead, and it's tedious because of the offsets of things. But let me just try it out here. Let me just see what the room looks like and what we've got going for us. I haven't created the dot object yet, but I have a sprite. It's 40 by 40 for right now, and I did go ahead and collision mask this to make sure it's only the dot that triggers a collision, because you don't need it to be the entire area, but we do need this area in some shape or form to make it easy for us to put this in the room. So coming back here and say, okay, let me create that dot object with the dot sprite and try to put one in the room and see what happens. You can see it's not 100% correct. Everything, because of the way the shifting, at least on mine, everything's off by 10 pixels. So one way or another, we need to fix that, and just to make it easy. And you're like, well, why don't I just set the grid settings to 10? Like, you could do that, but then every time you go to add a dot, it's going to be so tedious. 4. Oops. 5. See what I'm saying? 5, 6, 7, 8, 9, and that's how, that's where the object should be. But you're like, well, what if I just went ahead Now that I know this, go back into my dot sprite. And what I can do here is I can resize the canvas and shift everything over. I believe I can do this 10 pixels. So there we go there. I probably have to go back in because of GameMaker being GameMaker these days. Go back into this and fix this up. Yep, everything's been moved over. So 7, 7, 12, 12, oops, 17. Wait, 7, 7. Oh, 7, 17. And 12, 22. There we go. There is our entire bounding box now. And so now when I go to put these in the room, let me put this back to its original 20 by 20 grid. Now when you put these in here, it should be a lot easier for us. You can see now I don't have to think as much. And it's tedious, but it's less tedious than it was prior. So give me a couple minutes to fix up the dots. You go ahead and do that yourself. I will not make you watch and listen to me talk about dots while I'm clicking and talk about my life's philosophy or anything like that. I will just bring you back here in a moment when I have everything set up. All right, all the tediousness is complete, and this is the level. I just went ahead and opened up what the original level looked like, and I put all the dots around. The only thing I'm not sure of, and I'd have to go back and double check and practice and play the game over and over, did I put 2 dots in one space? I'm almost confident I did, because it's still tricky no matter what, however you set this up. But I have everything the way it's supposed to be going. And so the last thing I want to do is, it's not as easy as just collision destroy, because there's actually a gameplay element in here where if you eat a dot, you actually pause a frame. Pac-Man actually does stop briefly for that one frame it eats. And so that, so it's one of those things, if the ghosts are chasing you down, you don't want to get in the way of the dots, because then they'll slow you down when you're trying to escape. So I'm just going to go ahead into Pac-Man, into my step event, and this, before anything else here, is where I'm going to put that statement. And I'm going to say if. This is basically my collision event here. If place meeting x, y, if where I am right this moment is touching a dot, so dot equals true. Oh, and in this case, oh yeah, I forgot about that. This place meeting function is great when I care about, do I touch a dot, yes or no? But it's absolutely horrendous when it figures out specifically which dot of all the hundreds or whatever is there. So I want to use the instance place function instead. And so the same signature when it comes to x, y, and dot. But what I can say here, if ints does not equal no one, then I did collide with a dot. And what I can do here is I can do a return, just to make the return will kick me out of the step event, and I'll never do any of this down here for that one frame. So when I collide with the dot, basically it's a pause. The character will not hit this move contact solid, so I don't have to do any worries. And so then what I can also do here is say with, or maybe I can do it now, they've changed things up a little bit, instance destroy ints. So I can destroy that specific dot when I go ahead and do this. And one tiny little extra thing I did change is, apparently when I was looking at this, Pac-Man and Miss Pac-Man faces the left when it starts, not the right. So this is looking pretty good. So let's see how this works. So you can see Pac-Man does go a little bit faster when she's not touching the dots. You can see if you're playing it, you can feel it. You can feel that slight reduction on the speed as she's going around and doing the things she's doing. So things aren't perfect per se. Like maybe we should go ahead and change the bounding box slightly. I'm not going to for today, but I shouldn't be able to eat that dot. I can't point, you can't see me pointing, but I shouldn't be able to eat the dots like that one right here, the one that was right above here, because I technically didn't touch it. So what I would need to do is just to tinker with the bounding box a little bit, and I can use a collision rectangle to account for that rather than well, let's just do it. Let's just do instead of instance place, I can use collision rectangle. to rectify the situation. I just have to, it's more complicated though. So I have to say collision rectangle. Okay, so I have to say my Pac-Man is at XY, but maybe if I say maybe X plus 8, or yeah, X plus 8, Y plus 8, that is the upper left-hand corner of the collision rectangle I'm trying to get a hold of here. And if I say X plus 32, Y plus 32, remember my guy is 40 by 40, so this basically kicks out 8 pixels in each of the directions. And then I still want the dot. Do I want precise? No. And do I want not me? No, that doesn't apply. True or false probably would work here. And so now this should take care of it. Should, maybe not. My luck has been decreasing for a while now. And there you go. And now you see that dot doesn't get eaten even though I'm going around. So we just have to test it to make sure I didn't screw up in both up, down, left, and right directions. But left and right seems to be working because that dot right above me and right below me are okay. And so let's see, we can try up here and down here. And it's like, yep, the dots get eaten perfectly fine. I slow down perfectly fine as I'm doing that. And the dots don't get eaten. You do have to go ahead and do that. So that works for it. And if you really wanted to tinker, you could figure out exactly how far to modify the offsets to make this thing work. But there's really no reason to worry about that. We have it working with using this collision rectangle that kind of, it adds some precision to that collision. And we're dictating the collision rectangle and not GameMaker when it comes to using the actual collision detection. Okay, so Pac-Man, Miss Pac-Man, she animates, she eats dots, she moves around, she goes off the screen. At least for just this basic bare bones demonstration today, everything seems to be working fine. So now we're ready to go on and start adding ghosts. And I'm going to add one ghost to this for now, and then just to show you how, just to get the general ghost in here, just to make sure it's working, give it random movement, and then later we will go ahead and look at how the real AI works and give 4 different ghosts, 4 different personalities, and show you how that all goes. So I win my level while I talk, but now you can see that we're looking good here. I am ready to move on. All right, so you can see the ghost here. I'm going to save all of the heavy lifting when it comes to setting up animations for the ghosts until after I get this thing working with getting the ghost to move around and not have to worry about things like that and like getting stuck and things like that. So I just used the blue ghost animation that I have from my sprites. You can use whatever, excuse me, whatever you want. And so I have a sprite, I have them in there, and then it's kind of similar to the way Pac-Man works, but kind of not. And so let me go through the code. I have the code here. And so on a create event, let me stop this. Okay. So you can say, just like before, our speeds need to be divisible into, or divide evenly into 20 or 40. So these are very good numbers. And just to make sure everything is safe, I set the speed to 2. And I said direction is 180. So when the game first starts up, the ghost should move to the left at 2 pixels per frame. And I used the same exact code as the Pac-Man object for collision with side left, collision with side right. So then when the character finds the edge of the screen and goes off, it'll wrap around horizontally just like Pac-Man will. And so the step event, this is where things get a little iffy here. So let me just talk to you about what is happening, and let me adjust my code since I got this thing working. Forgot about this. And so what happens is we have to test and say we could make this more efficient, but rule number 1 is always get it working, and then rule number 2 is, if you care, make it work better. So right now I'm just checking on a frame-by-frame basis, since this is a step event. I'm saying, hey, let's try to see if there's an opening above me, below me, to my left, and to my right. And so I'm setting up an array of choices, which is empty to start, and I'm saying that off the bat, I have no choices. But I should always have at least one choice, which is, you'll see as things go. You would think it'd be behind you, but if I just randomly pick behind me, half the time I'll go and I had it working earlier, and it was just the character would just go back and forth and back and forth and back and forth. The character never truly really moved anywhere because it would just go left, then right, then right, then left, and right, 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 left, left, right, left, right, left, and so it didn't really play out very nicely. And so all I do here is for each direction, so notice this is the ultimate one. This is checking to go to the up. This is checking to go down. And they're all the same, slightly different. So let me just write this, let me just comment this in here. 180 is left and 0 is right. And that's why I have the first if check in here. I say because if I'm going up, I can't go backwards. That's one of the rules of Pac-Man, is when I hit the decision points and all that, the ghosts, Pac-Man can all the time, but the ghosts cannot go back from where they came. They cannot just do a 180 and go backwards. So this is how I make sure that the ghost doesn't do that. I say, okay, if the direction is that the ghost is going right now is anything but down, then I can go up. So that's perfectly fine when I hit at, so if the direction isn't 270, then cool, I can do that. And what I can do is check to see if there's a wall above me, x, y minus 2 wall, and if there isn't, add to the array. And that's all this is doing, is saying, okay, choices at the 0 location is going to be 90 degrees, and I'm going to increase the choices because I have now I have one choice. And I'm just going through and adding all of the different directions using the same logic. If I'm trying to go down, well, I can't go back up again. So if I'm, as long as I'm not going up, I can go down. And I just check now below me, y plus 2, and I add it to the list. You can't really hard code it because you could have, technically, I guess if you want to think about it, anywhere up to from 1 to 3 choices. As long as you don't have any dead ends in your room, the character will be able to move on to and pick a choice. Because when the ghost gets to here, don't mind the difference here with but if it gets to here and it's going this way, you can choose one of the 3 different ways, because I can go left, I can go up, I can go down, but I can't go. I could technically go backwards, but I really can't because I just ruled out that I'm not allowed to do that because I'm already going to the left. I can't do a 180. So that's all that's happening here, just on a case-by-case basis, just checking on a step-by-step basis as well, which of the 4 directions I can go. Can I go up? Can I go down? Can I go left? Can I go right? And then I'm setting the direction to one of those choices. I'm using random of choices minus 1, because if there's 3 choices, that means that they're in the array, it's 0, 1, and 2 to choose from, and random is an inclusive choose function, or an inclusive random function. So number of choices minus 1. If you forget this minus 1, your game will crash because it'll access an array element it's not supposed to, and GameMaker will have a fit about that. So it sets the direction. Right now, like I said, in a couple minutes, we will add the actual final AI to this. But right now, when it gets to a decision point, when it hits like an edge and go, well, should I go up or down or left? It'll pick one of the available options randomly and then just continue moving in that direction. So this is what happens with that code in place. And I'm not going to sit around forever and a day because this thing is completely random. Oops, I got the ghost. I've got the ghost on top of or below the dots. Is that cool or not? I don't know. It depends on how you think about it, right? If the ghost is see-through, partially see-through. But we can fix that, but not right this moment. But you notice it hits a decision point, it never goes back, and there it goes around, and it'll take an hour for the thing to get back over here. I already tried it out earlier, waiting and waiting and waiting, because the random number generator is exactly the same values every time. But you can see the ghost either continues on. It depends on the choices, right? There's either 2 choices, or like it gets to here, there's 1 choice. If he's either way, he can only go left if he's trying to go up, and he can only go down if he's going to the right. Excuse me, because the direction you came from is not allowed. They're really, as much as you're going to will it, it's going to take forever for it to get over here. But it does come wrap around just like the Pac-Man character does. So that is the thought process. Uh-oh. Oh, what in the world? How did Pac-Man? I don't even know what I... Okay, that's a bug. We'll have to fix that. That's an interesting bug. What in the world happened? I must have hit the button at the exact wrong moment and just got shot out of here or something. I don't know. But and I can't move at this point. Pac-Man is stuck. But anyway, but that's the whole thought process. Figure out which directions you can go, and then it's real easy if there's only one direction to choose from, but it gets to be a little choosier if there's two or more, and that's where the AI comes in. Which one will it choose so that it follows whatever we're trying to do? Is it smart? Is it timid? Is it scared? You know, like what is the behavior? And depending on which direction you choose, you can totally get that behavior, because if you've played Pac-Man enough, you know that the ghosts have distinct personalities. But again, what's interesting here is that the code up to this moment in time, up to there, we don't really have to change this. We may have to change the order of operations, depending on which directions win out when there's like a tie or something like that. When it comes to, like if I want two different directions and they both get me to the same place at the same time. But everything up to there should be almost 100% the same, if not the same. And it's only when we get to this line of code that we have to change our thought process to do more math to figure out a better way to choose than randomly. So that's where the final step of this is going to go. Okay, it's time to push forward a little bit. Now we have a random ghost. It was blue a minute ago. I spent some time and I turned him into a red ghost. I'll describe everything. But other than that, the ghost pretty much does the same kind of stuff. I did end up having some issues with the ghost moving around. Let me just kind of go through a little bit of everything here. So I created the sprites for the ghosts. Again, everything's 40 by 40. I have two images, two animation frames for the down and the left and the right and the up, all four directions. 40 by 40. I went in and I changed the collision mask, at least for right now, to be full image. And we need that for the movement. Maybe not for collision with the detect if we eat Pac-Man or what, but for right now, I'm not worried about that. We'll cross that bridge when we get there. But just like Pac-Man has the 4 animations, so does the ghost. And then I also changed this. Maybe I did, maybe I didn't, depending on it. I changed it so much, maybe I put it back to how it was. But I changed the sprite or the bounding box settings. 0202, 0719 for my version of Pac-Man. And if you're not using the exact coordinates as I am for things, then you don't really have to worry. But I was getting that weird Pac-Man bug, and I was getting bugs where the ghost got stuck in walls and things like that. But by fixing all this up, I think I've pretty much alleviated those issues. Same with going the right sprite here, where I just changed things up and I start at 38 instead of whatever I might have been changing, whatever it might have been before. So those sprites get added in. I'm not using the blue ghost, the eaten ghost anymore. And so now I can actually go into the objects. And I say, because I changed this here, I just said forget it. Because it's one of those things where I've been working this video over a couple of days now, and I do this and that. I come back and I forget what I'm doing. So for right now, I just hard coded instead of having my collision events from earlier. I just hard coded my values, and I say, okay, if I collide with the thing on the left, just move my X value to 929. And what is that? Where's the room for this? Hello? Come on, there we go. So like 929 is right here, right on the edge of a boundary here. So, and then with this, it won't collide because I changed the bounding box and everything moves. So I said, when you're seeing the game in action, hopefully it doesn't take too long to get one of them to cross the boundary, you will see that there's 8 of them, for God's sakes. Come on, let's go. And nope, 50-50 shot, nope. What are the odds? 50-50, there it is. And you can see them going across. And the same will apply going to the right-hand side. I'll wait 10 more seconds at the most here. Oh, come on, getting there, nope, getting there. Nope, that's the problem with randomness, right? So it's fun, but nope. There, nope. Anyway, So it just, I use the value for the other side of this. If you collide on the right-hand side, just say the x is 311. The band, of course. And so the ghost, I did the same for the ghost. I just changed that up so that the x is 929 and the x is 311. And then what I did here for the ghost is, in the create event, I added an array called images. And the reason I did this is because this is just one ghost. This is the red ghost. It's the easiest ghost to do the AI for. So that's why I picked it. And so I said, here are my images. This one faces right, up, left, down, because this is the 0 direction. This is 90. This is 180. This is 270. If you take those direction numbers, divide by 90, you get 0, 1, 2, and 3. So I'll be able to do this very easily when it comes to just figuring out which image to draw at any given time. And you saw it already works because I already proved it to you. I showed it to you working. And so the thing is, I also played with depth settings so that the ghosts and the Pac-Man are always on top of the dots, especially the ghosts. And then I also made it so that the wall, or not the wall, these side things are below everything else. I'm sorry, above everything else. Which one was it? Depth -3. Whichever it is, you can see, well, when you run it, you can see that the ghosts don't really look like they're, oh, but they do look like they're over. Maybe I put things in the wrong order, but again, that's an easy fix if you play with the depth settings. If you like it this way, then you don't have to touch it. But if you want it the other way, you can go ahead and do that too. Anyway, so just saying. So what I'm doing here, outside of the depth settings, is I'm using this images. So let's see, red ghost, step event. And so down here, I just added one piece of code, and I also added an if check around what we were doing earlier, because this shouldn't, it's one of those things, this should never happen, where the number of choices of how many directions the character can go in any frame should be 0, or I'm sorry, should be above 0, because as long as there's no dead ends, there's always a direction for the character to go. But however, earlier on, I was having some issues and the game was crashing, so I just threw this around here. So if you end up with a bug situation, you don't change the direction, so the character, especially if they're outside the bounds, if they're wrapping around the screen, they don't have to worry about moving. So and then this is all this is all I added here. And I just said, okay, take my direction, divide that number by 90, because it's going to be any of the 4 cardinal directions, apply that to the images in array, and supply that as the sprite index. And as you see, it works. That's all. Everything else is exactly the same as we've done before. And so just one more time going with that, you can see that the 4 ghost sprites, now that maybe you pay attention a little more, you can see that the eyes are facing the direction they're going, either right, up, left, or down. The sprites look like they're supposed to. And I can move around and do the things I'm doing, and the Pac-Man goes off the screen perfectly normal, and you can't ruin it like you could earlier. I don't know what I was doing to ruin it, but you can't ruin it like you could earlier. So that is how I got the red ghost going, at least kind of exactly to the same place as the blue ghost, because it's still random. But the one thing you might notice here on the Pac-Man character, Miss Pac-Man here, is there's a red X. And so the final thing I did for our ghost is to give give you as a developer the idea of where this ghost is trying to get to at any given frame. So I took this over, I said draw self, draw a red X on Pac-Man's position. And that goes for every ghost, so every red ghost will be pointing right on where Pac-Man is, because for this ghost, the AI is supposed to be this way. And how do I know the AI is supposed to be this way? This video right here by Retro Game Mechanics Explained is exactly what I'm talking about. This wonderful 19-minute video pretty much tells you everything that went into the design of the AI for the original Pac-Man game. And so I'm not going to go into the details. That's up to you. I will explain the details, but I'm not going to go through the reasoning behind everything. But just to say that at 642, they describe the red ghost here and how it's going to work. He's got the simplest way of doing it. And then basically, the red ghost is just trying to create a advertisement for Disney Plus. And so I can skip my ad here and come back, and you can see that the red ghosts are always just trying to latch on to wherever Pac-Man is and trying to find their way there. So there's a couple other rules along the way, but let's get this red ghost from being randomized to finding the best path to Pac-Man no matter what. So another little detail here is that I changed this up on the red ghost, and according to the rules, just if you watch the video, we try to go up before we try to go left, before we try to go down, before we try to go right. So if there's a tie, like if we're trying to figure out two different ways to go and one of them and two of them tie, then this is the tiebreaker. So if it would, the up will go before left and so forth and so on. And so this is, I haven't touched the code just yet, but basically instead of running through this, what I can do is set up a couple more variables. And I can say new direction, and I'll say equals -1, just in case. And remember down below I talked a couple minutes ago about the fact that this number of choices could be greater than 0. And I don't actually need this anymore, these choices and the number of choices, because this new direction is going to handle it for me. And then the distance to Pac-Man is going to handle everything else. And I'm going to make this just a hugely large number. There's no way this, just to make it so that when I try at things, try to find out how far away I am from Pac-Man, then everything's going to turn out fine. So I can get rid of this. Boom. Let me just get rid of this in all 4 places. We're going to replace this with the new code. And if the new code works out, everything should be happy. Okay. And then down here to say if new direction, if new direction does not equal -1, instead of using choices random or whatever, we're going to say direction is new direction. If this works out properly here, right? Oops. If new direction does not equal -1, so we're kind of working our way in here. And so this will break, of course, if I try to run this in the moment, or will it? Well, let's see. Nope, doesn't break. But all the ghosts go to the left because that's how they started, and now they don't know how to do anything else because we broke all the code. We took all the code from inside of here and figured out what was happening. Okay, so now what I want to do is if this is up, I want to see how far it is from Pac-Man to the ghost if he were to go up 1 square, basically is what's going to happen here. So there's a function, I'll call it dist here, and it's called distance to point. Or let's see, distance to point, or just let's see, point. There's point distance. I want to use it generically because I want to say, okay, I'm going up, so my x value, but my y value minus 20 pixels. That's my value. But how about Pac-Man's x? How about Pac-Man's y? And then is there another one? Nope, that's it. And I say, okay, so how far is it from Pac-Man to me if I went up 1 square? Because we're just testing to see, is that going to make it an easier time to get to Pac-Man if the distance, and it's just as the bird flies, as the crow flies kind of estimate here. And you could tinker with this. I think this is going to work. I'm doing this one live, but I say now if the distance is less than the distance to Pac-Man, then my direction is going to be, remember, it's the opposite here. So my new direction is going to be equal to 90, and my distance is going to be equal to this dist. Distance to Pac-Man is going to be equal to dist. And we're just going to pop this inside of those blank if statements 4 times now, because we just have to try each of the 4 directions. Try going up, and if you can, then if it makes you closer, then go up. Then try to go left. So left means to try to go -20 in the y direction. And then this would be 180. And then the same with dist. And say tiebreaker, it has to be less than or equal isn't going to work. So just trying this another time with 90. So this should make it 270 if it works. But if this is going down, this is going to be a plus on the y. And then the same just to finish up here. If I do this right, this should be, if I'm going 180, this is a minus on the x. Let me make sure I did plus on, oops, minus x. Try to go left is a plus here. Sorry about that. Say that's the fun of this, is you'll know right away if you screw things up. Let's see. Let's see. Up is y minus 20. Left is x plus. No, left is x minus 20. Oh, yeah, I'm talking myself into a problem here. Down is y plus 20. Right is x plus 20. I don't. Left and right. What's the difference, right? And so if it's not 180, it's going to be a 0. And let's see what happens. I got 8 ghosts coming after me now. Here they come. They got me. They're all following that pattern. And you can see now they're in a holding pattern here because they're finding the best way to get to me on every game frame. Here they come. Now they got me, and then they're coming around again. How do they get me? They're coming up. Let's see. Wherever I go, they will get me now. Instead of being completely random, the ghosts are, they got me. Uh-oh, that one don't. So now just wherever I go, come get me, guys. There's no way out. Here they come. They're going to get me no matter where I go. So that's the red ghost. That's the easiest AI, is because, you know, it's exactly, they're trying to go exactly where you are, and there's no way out. There's no way, you know, you can just run away, but you can't hide. Pretty cool stuff, right? So let me go back to the code one more time just to make sure you guys have that so we can push forward and we can start generalizing this, because now that we have this code, it's really just a matter of figuring out where the Pac-Man is, right here, and then figuring out where I am. I'm trying to go, and then the code is going to be pretty much similar, pretty much the same inside of here. It's just the ghosts are going to be slightly different when it comes to that. Okay. So here it is. So new direction is -1. Maybe I don't even need new direction. I could just set it, but I'm not going to worry about that. But it's just to say, what we're changing inside of here is to say, okay, if I try to go the direction I'm going, will it give me a shorter path than anything else that I know up to that point? Because the whole point of this is to find the shortest path, you know, pathfinding kind of algorithm. Give me the shortest path from point A to point B, and on a frame-by-frame basis. And it knows if I try to go left or right or up or down, it knows. So again, if I'm going up, minus in the y. If I'm going left, minus in the x. If I'm going down, plus in the x. I'm sorry, yeah, plus in the y. And if I'm going right, I go plus in the x. Okay, so that works out for red ghost. And now part of this is the tediousness. I'm going to set up all 4 ghosts and get all their graphics going and all of that stuff. And we're going to set up all 4 of the AIs. We got 1 down and 3 to go. Okay, so I went ahead and I got animations for all of the pink ghosts, the down, the left, the right, and the up. Again, all 40 by 40. Oh boy, I do have to fix this up. GameMaker trying to be nice to me. 0, 0, 39, 39. So I got to use the full images again for everything just to make sure everything is pixel perfect and we don't have any issues with the movement around the screen. 0, 0, 39, 39. All 4 of them. And it's the same basic rules as what we've been doing. We're going to change things up just slightly. 0, 0, 30. Oh, that one's fine. 0, 0, 39, 39. 0, 0, 39, 39, 0, 0, 39, 0, and 0, 0, 39, 39. Okay, so now I can go ahead and duplicate the red ghost. And it can be pink. And I can go ahead and just give it the new pinky sprite. And give it the left eyes to start. In the create, I can go into this guy and just change up. Just change it to pink for everything. And at this point, even if I just go ahead and I just go in here and I replace half of our ghosts with pinky ghosts, the graphics, everything should be the same AI-wise, right? It's just the only difference should be the colors of the ghosts. We can test this out. So, oops, working. I thought I crashed it or something. So here I go. So let's see, down, right, down, left, up. Okay. And so right now the pink ghost and the red ghosts are happy in their little world. The graphics, see how quick it was to change up the graphics? Wasn't that pretty slick? That's all it took was a couple, just a couple seconds to change up the graphics on that. At least when it came to the code. Getting the graphics from the artist, that's a whole nother story. But anyway, so coming back, so we're good now. And so now it's just a matter of figuring out where the ghost is searching for the Pac-Man character. And let me show you how to do that. Okay, so for the going back to the video, right around the 7-minute mark, they describe what the AI is. And for the AI for the pink ghost is always trying to go basically 4 squares ahead of wherever Pac-Man is. So if she's facing here, then you're supposed to, like 1, 2, 3, 4, they're trying to go here. And it depends on where Pac-Man is facing, left, right, up, or down. And if you watch the video, you'll see that there's either a little bug or just a little something in the code. If Pac-Man is going up, facing up, you go 4 up and 4 over to the left. And that's just the way it goes. So that's the target position. But all the other code stays the same, like try to go left, try to go right, try to go up, try to go down. But instead of going against Pac-Man's position, what we can do here is set up an array of stuff here. And I can say, okay, I'll call this X direction, the X directions, XDIRs, array equals, and I say, okay, and then I'm going to use Y DIRs for the directions. It's like, so I don't have to write a bunch of if statements to handle this. And I could say, okay, in the 0 direction to the right, you're gonna, like Pac-Man's gonna go positive 80 in the X and 0 in the Y. If I'm trying to go to the right, if I'm trying to go up, I'm gonna do, like I was describing before, for whatever reason, up is negative 80 and negative 80 for Y, for both X and Y. That's where Pac-Man, or that's where all the ghosts are trying to go. And so for left, you're trying to go minus 80 in the X, and you're trying to go 0 in the Y. And for down, you go 0, and you go positive 80. You don't have to use the plus signs. I just have it just in case. Okay, so that's how things are looking here. And so what I want to do is figure out from this what direction Pac-Man is going, and then figure out some offset. And I'll say var here, var there. So just put all these, I did just so these are local variables and not member variables. And so what I want to do to finish this up here is just, let me steal this first just to prove this is working. And let me go into the draw event for this, make sure this is Pinky here, okay, in the Pinky Ghost. And so here we go. So I have my X direction, Y direction. And so what I can say is I can say var dx equals, and I can say X DIRs, and then kind of like I showed you earlier, I can take the Pac-Man's direction and divide it by 90. And I can do the same for the dy. And use dy, Pac-Man direction. And now what I can do here, instead of, this is where I'm drawing the thing. But instead of drawing it halfway, I can add this dx value to here, this offset, and add this dy value here. And let me, oops, did I change it? Nope. And then what I can try to do, let me see if I'm allowed to draw set color. Let me see if there's a C pink. There's no C pink? Oh no. And so what is pink? But I don't know. What is pink? Let me look that up, and I will get back to you in 1 second. So I am told that this is pink 254, 184, 198 when it comes to RGB values. And so I'm just going to say take Pac-Man's position, move over 15, then use the dx value, and then use Pac-Man's y plus 15 plus dy, and put an x there. And you will see when I get this going, and it will come out correctly. You can see the red is always going to be right on Pac-Man. And as I was saying before, if I'm going right, it's ahead of Pac-Man 4 squares. If I'm going left, it's 4 squares. Down is 4 squares. But only when I'm going up is it 4 squares up and 4 squares to the left. But other than that, all I have to do now is change this up. I can, like I said, this works. These are correct values. So now all I have to do is go back into the step event and use these things over here, kind of like I did before here. Let me go in one more time and steal these 2 lines of code to figure this out. Once you have this working, you can eliminate the draw event, so you don't I don't have to worry about it making be efficient inside there, because I'm going to eliminate that in a little bit anyway. But over here, I say, okay, there's my x ders, there's my y ders. And so now all I have to do is just go in here and just say plus dx plus dy. And yes, it's a little tedious, but we'll copy this the rest of the way, because the other ghosts basically kind of do this as well. Plus dx plus dy. All 4 of them, make sure it does plus dx plus dy. And so you can see how the ghost has a different personality. They're not necessarily trying to get you, but they're trying to get in front of you. And so the one ghost is trying to get you, one is trying to go in front of you, like to block off where you would think you would want to go next. So, okay, so here we go with there. So let's see. They're trying to get to that tile up above. See how the orange ghosts, I'm sorry, why do I keep calling it whatever? You see the pink ghosts keep going around because that X, can you see that X in the corner there? That's where they're trying to get to. So like in this one, it's going to be all weird because the pink ghosts are trying their best to get to that X that's in the pen. So they're going to do all sorts of crazy stuff to get there, whatever it takes. And so now, maybe now they'll circle around it. And the red ghosts are on to me because, they get to me and then they double back around next time around. So that's pretty cool. We got 2 of the 4 ghosts here, the AI, and we can see on the screen, maybe use a font to show a bigger X or something. But for right now, I think I'm happy with that, to know that that's what's happening here. So all the pink ghosts don't actually try to get me. They just try to get to that square below me. So the pink ghosts, oops, that one got me. But in essence, it's more of an accident if they get you, because they're not trying to get you, they're trying to get to the square ahead of you. So we got 2 ghosts down, 2 to go. All right, moving on to the orange ghost. Apparently I'm learning that one of my monitor's colors are completely different than the other, because the orange does not look the same, but that's a weird yellowish color over here on my monitor. But I did the same thing. I got the ghost down, the ghost left, the ghost right, and the ghost up sprite. I had to change all the collision masks, 0, 0, 39, 39. Everything's upper left-hand corner centered. 2 frames of animation. Every one of my ghosts is running at 10 frames per second. Maybe even Pac-Man is. Nope, Pac-Man's running at 30. And again, you can adjust these things as you see fit. But I've got my orange ghost, and what I did this time was I duplicated the red ghost, because most of the work here, if looking at that video, is using that as a placement here. So I just took the orange ghost, I updated the images to be orange ghost right, up, left, and down, because I just created them. So in this case, the orange ghost would work exactly like the red ghost, except the colors would be a little different because it's using different images. But as of right now, the code is identical. The code to actually move the character around. And the only difference here, if you go and look at that video again, right around the same point as the other ghosts, is that if you are within 8 tiles, which is like basically 160 pixels of Pac-Man, you will try to jump right in on them. But as soon as you get that close, you get more timid and you try to move what they call in the video into scatter pattern. So I just have to go ahead and just fix this up here and just say this dx value is going to be Pac-Man's x, and then my dy value is going to be Pac-Man y. Payman. Okay, and then for the moment, I just have to go in here and just change this to dx dy. So right now, nothing is really changing. I'm like at the end, I'm doing what's called refactoring. I'm changing my code, and at the end of the day, even though I changed my code, the behavior ends up being exactly the same. So if I run this just to make sure, then the orange ghost should go exactly like the red ghost, follow right behind him. And the pink ghost, don't have to worry too much about. He'll go around in circles, do what he needs to do. So after that little change, everything is still good. I said the pink ghost does what it wants, but the orange ghost follows right behind the red one because they both have identical code to get them to the same spot. And so I'm good there. So then all I need left here is just to say if, let's see, point distance. What's the distance between 2 points? And if it's less than 160 pixels, we'll fill in that gap there in a second. Then my dx value is going to be something, my dy value is going to be something, and I just have to look at my game and I go, that ghost goes down to this position down here. So something like this, let's say 350, let's just use this corner point, 350, 680. Oops. 350, 680. Oh, what? 50. Keep talking to myself. 350, 680. 350, 680. And so what's the point distance? The point distance is, since I'm in the orange ghost now, I say, okay, x comma y comma Pac-Man comma x comma Pac-Man comma y. How much distance is there between those 2 points? My position, and the Pac-Man's distance. And if it's less than 160, then my goal tile is the lower left-hand corner, and that's just going off what the video tells me. And if this isn't true, if the distance is further away, then this stays put. So let's see if this changes anything here. Orange, yep, it already does. Orange ghost is doing different things. He locks in on me, but then he gets timid. He does not go you see how he's not going after me? Because for that brief moment he's going after me, but then he goes to scattered pattern because he's trying to get down here. And then when he comes back around, he goes, oh, I can actually get closer to Pac-Man, but then, oh, I can't do it. And so all the ghosts so far are getting different personalities. This is pretty cool, right? So 3 down. I saved the most complicated one for last. It's not, I mean, it's complicated, but it's not crazy complicated. But now you can see, let's see that orange ghost. Oh, I needed to draw the X. Let me draw the X on him here. Go in here. Let me change this up so it's a little easier to see. I think I can get orange. I think orange is a color here. Yep, orange is a color. And just for this, I'll just move it over a little bit on the screen so we can see it. Maybe you can see it, maybe you can't because Pac-Man, but the orange, it's there, and then once you get close, there's this. Oh, never mind. I need that dx and that dy. Okay, here, let me go back. Duh, right? Silly me, silly me. I'm just for the sake, because again, when we do this, the dev code generally falls away immediately, or at least pretty close to immediately. So once this is all said and done and I'm happy with this, I can erase all this code. This does not have to be efficient in any way when it comes to what's going on here. Dx comma dy, and I'll just say dx plus 15, or I'll just leave it alone. And okay, so there's my orange. Now you can see the orange, and you can see it moving. He's trying to get Pac-Man, but now he's trying to go back to the lower left-hand corner. Trying to get Pac-Man, trying to go to that lower left-hand corner. And so it's pretty cool. That's why the ghost, looks like he's coming after you, but then he's like, oh, maybe I'll rethink it. But again, there's only so many paths these ghosts can go, so it makes sense that they would, depending on where you are and depending on certain factors, would go ahead and still go over Pac-Man, even though they're not directly trying to do that. Okay, so one last ghost, that little blue ghost, and I'm going to call it. I mean, you can do all the scoring and lives and all the other stuff. That's something that you guys should be able to at least start pushing your way toward. Okay, so let's do the blue ghost. Okay, so I finished everything up for the blue ghost again. The same thing goes 40 by 40, 0 to 39, 0 to 39, 10 FPS, 2 animation frames. There's my blue ghost down. There's my blue ghost left. There's my blue ghost right, and there's my blue ghost up. So the only time, this is the more complicated one. So I'm going to go into the blue ghost now. Go into my create event and change up. I say all my images are changed. The blue ghost, blue ghost, blue ghost, blue ghost. And then my step event, This is where things are going to change. So the rule is we got to look 2 tiles ahead of us. So I'll say 40. Instead of 4 tiles, it's 2 tiles. So each tile in our game is 20 by 20 instead of 8 by 8 like the game did, because we made everything larger to accommodate just the larger monitor, larger screen. And so this does not have to change. What is my X position? What is my Y? What is my direction? And so this fixes up and says, oh, the dx and the dy. So this is the same rule. 2 tiles in front of Pac-Man instead of 4. So then dx dy right now, dx dy is, however you want it, is 2 tiles ahead of Pac-Man. Okay, so then what we do is then we figure out a line. We basically draw a line from, I'll just call it dx, and I basically draw a line from red to the red ghost to that spot, the dx. So it's essentially red ghost dot x minus, it's always from, I believe, you know, don't hold me to this 100% since it's been a while and I'm just talking and it's early in the morning for me, that the red ghost, 10 o'clock, but anyway, kid's been up for a while. So red ghost dot x from the end point to the beginning point, something like this. And then the y position would be the same thing, where I say, okay, take my red ghost, subtract off my stuff here, that's my dy value. And then instead of adding this thing, I should subtract it. And if I'm wrong, I'll be off by a little bit, but we'll try it out. So dx minus equals ddx, and dy minus equals, I'm sorry, the other way around. ddx minus equals dx, and no, dx minus equals ddx, and dy minus equals ddy. And I just have to go in here, and instead of adding this thing to Pac-Man, that is just the position I'm trying to get to, is that dx and dy. Kind of like I did before for the other. So it was kind of like a little hybrid code here. It was kind of like the red ghost, kind of like the pink ghost. So but you don't want to have to write that out every time yourself. So that's why a little copy paste, as long as you kind of have a feeling for where you're going with things, saves you a lot of hassle. Hopefully this saves a lot of hassle. Let me borrow all of this code so I can do the draw event, so I can see if that's exactly what I'm supposed to be doing. So dx dy. Let's see where this goes. And I'll use blue color instead of whatever it is that was, pink. Let's see what happens. And if it doesn't work, then we'll figure it out. Okay, so let's see. Blue ghost. Where is that blue X? Yeah, it's not working 100% like I expected. So that blue X isn't anywhere on the screen. So I'm gonna do a little research here, and I'll let you know what I did wrong, and then we'll fix it up, and then blue ghost will be doing what it's supposed to be. All right, just a little math. I didn't write it out, so if I wrote it out, it would have been perfect the first time. So here's the step event. This is the code that we're discussing here. The dx and the dy value is what we're trying to get to. So again, 2 squares ahead, I have my arrays. This time around, I changed this up so I could say, okay, the target dx dy, the target point dx dy is my Pac-Man plus that offset, so I can get to the exact square. And then what I do is I figure out the line from that point, dx point, to the ghost's point, and then I basically reverse that 180 degrees. And that's, instead of adding this value to the dx value, I subtract it off. And so what happens here is when I run this with this code in this place, is you can see that the blue ghost, you can see the blue X, and now you can watch as things are going. The blue ghost basically flanks where the red ghost is. I mean, it's not because everything is in flux, but you notice that basically wherever the red ghost is, the blue ghost is trying to get the complete opposite side of it. Wherever Pac-Man is facing up two, let me move this 2 squares ahead here. Let me get this to there. So you can see now, let's watch this here. The red ghost is coming around, and then the blue ghost is basically on the other edge of that. And so pretty cool, right? My only question is, when it comes to this is, oh, because it's 2 squares ahead here, and then Pac-Man, yeah, so it's like, it's interesting, but it's working. It might not be 100% perfect, but I'm trying to get perfect AI, but at the end of the day, this is looking good, and the behavior is what I'm looking for in this ghost, is to kind of come after me, but not necessarily come after me directly, because it's flank, and then basically come after me if it's convenient to do so. But as you can see here, with all these X's and everything, like the target tiles for all the different objects, you can see everything going crazy here. You can see how everything changes. The blue ghost is pretty much the only one that changes continually, because it's the only one that changes based on the result of every other, or the red ghost. Everything else is basically based on where Pac-Man is in relation to it. But that's it. I'm gonna call it a day here on this video, since oops, I gotta make sure, where are all the where are all my ghosts? There's 2. Where's the blue one? Did I lose the blue? Oh, I don't even pay attention. Did I lose the blue one off the screen somewhere? Oh, no, there it is. I don't know what happened. That was weird. But anyway, I think it's a pretty good demonstration about how to get, with a little bit of ingeniousness and a little bit of hard work, we have an AI that we could be happy with, and we can say that, we pretty much accomplished what Pac-Man did way back in the day. I don't know why they get together and they can't get them apart. That's the only thing that's weird to me. There we go. But anyway, same with the blue ghost, but can't get the blue ghost away from that one. I think it's this one. But anywho, I don't know where. I'm not paying attention enough to see that it seems like it disappears out of nowhere when it does. I'm not 100% on this. Like, I'll have to pay a little more attention. But anyway, if you have any questions or concerns, as always, swardb@cod.edu is a great way to get a hold of me. Comments here on YouTube. If correct me if I'm wrong. I mean, this is a long video. This is a complex video. I might have said something incorrect or done something incorrect. I'll correct it. Just let me know. I'm not infallible. Good Lord. Oh my goodness, I am not infallible. I am very fallible. So thanks for sticking it out with this video. The next video I'm going to make is like a Zelda-style adventure game. So I'm going to show you guys how to change cameras and have weapons and different, and maybe if we get to it, we'll have AI states for characters so they can chase you down and then they can retreat and things like that. We can introduce more complicated AI into a battle mode with some Zelda elements. So anyway, thanks everybody for this for sticking with this video. Have a great day, and we'll see you next time.